So let's take a look at completing the square. The equation we're going to use to look at is up here in the top left-hand corner, y equals x squared plus 8x plus 10. Now, the first thing I did was, with these algebra tiles, I represented what we start with. So here's my x squared tile, here's my 8x's, and here's my 10 units, or 10 unit squares. The purpose of completing the square is to arrange these tiles to actually look like a square. So let's blow this up here and see what we have. On the left-hand side, I have a y. This double bar represents the equal sign, and on the right-hand side, I can arrange it with the x squared in the top left corner, and then I have my 4x's here and 4x's here because we want it to be a perfect square, meaning that the two side lengths have to be the same. And then I take my 10 units and I start filling in this bottom part. As you can see though, I'm missing 6 tiles to make a perfect square. They go in these 6 spots. If I need to add 6 to this side, then I'm going to also have to add 6 to this side. Y plus 6 is equal to x squared plus 8x plus 16. However, we also know that the way to write an area, instead of adding up the individual pieces, would be to look at the base times the height of the square. And because it's a square, both the base and the height will be the same. Here you can see the side lengths are x plus 4 by x plus 4. So the area of this square could also be written as x plus 4 in parentheses squared. So down here, if I want to rewrite that, I'd have y plus 6 is equal to x plus 4 in parentheses squared. The final step to get it into vertex form would be to get y by itself, and to do that we would need to subtract 6 from each side. Now be careful, because you can't subtract 6 inside the parentheses. In fact, it's just going to stay the way it is right outside the parentheses. So this vertex form is going to be y equals x plus 4 in parentheses squared, and then minus 6, which gives you your vertex at -4, -6. Now, if you need a minute to copy this down or take this all in, go ahead and pause the video, because I'm going to actually erase this and do another example for you. The example we're going to look at now is y equals x squared plus 6x plus 7. Except this time I don't have the tiles necessarily to help us. So we're going to do a general area model that would represent where the tiles are. Now, because we have an x squared tile, we know that that's going to go in this upper left-hand corner. The trick is, we know that it needs to be a perfect square, and we have 6 x's to fill in to these 2 spaces of our square. So if we have 6 total to be split evenly into 2, I know that I'm going to have 3 x's in each side. That means that each side of the square is going to have x plus 3 as its dimension. Now, how many tiles would need to go here in order for it to fill in this perfect square? Keep in mind, we already have 7, but how many do we need to add? That's right, we'd need to have 9 total, because 3 times 3 is 9. So we need to add 2 more. But again, if we add 2 to this side, we need to add 2 to this side. So this brings us to y plus 2 is equal to x squared plus 6x plus 9. But we know that x squared plus 6x plus 9 is the same thing as this square here, which is also represented as x plus 3 in parentheses squared. So we have y plus 2 is equal to parentheses x plus 3 in parentheses squared. And then the last step would be to subtract the 2 from each side, which gives us y is equal to x plus 3 squared, and then minus 2. So the vertex is at -3, -2. Again, if you need time to write this down or take it in, go ahead and pause the video at this point. But we're going to do one last example, because I bet some of you are wondering why, or what would happen if that number of x's can't be split evenly into 2 parts. So let's go ahead and shrink this one down so it's not really in the way. And let's work on a new equation here. This time we're going to do y is equal to x squared plus 5x minus 2. So let's go ahead and start by building the area model for this. I know the x squared is going to go in the top left corner, just like always. And it splits into x and x. Now, I need to evenly split the 5x's into these two spots. 5 doesn't split evenly. But remember, fractions can be your friend sometimes, and therefore 5 can split evenly into 5 halves. Try to not get in a habit of doing decimals, because as you go further on with quadratics, you're going to want to use fractions. That means that each side of our square is of length x plus 5 halves. That means what would have to go in this square, what we need, would be 5 halves times 5 halves, which is 25 over 4. Now, we have a negative sign up here, which we haven't really had many dealing with negative signs. So we don't really know what that means, because it means we're actually missing 2 tiles. So we would need to fill in an additional 2 tiles. Now, the easiest way to think about this is do the easy thing. Add 25/4 to both sides and just leave that negative 2 hanging out. What I mean by that is you have y plus 25/4 is equal to, and then you're still going to have the x squared plus 5x, and then you can add the 25/4, and then don't forget that you still have that negative 2 hanging out here. What that allows you to do is group this part, which is really the representative of this square, which has an area of x plus 5 halves in parentheses squared, together. So that means that this simplifies to be y plus 25/4 is equal to x plus 5 halves squared minus 2. Notice that the red boxed in area simplified to be the area of that square, since that was the part that was representing the square. The final step would be to subtract the 25/4 from both sides. So I have y is equal to x plus 5 over 2 squared. I'm going to go ahead and write down this extra step. I would highly recommend you doing it too, so you get used to how you do this by getting that common denominator, and then do your last step as actually combining those two numbers together. Negative 8/4 minus 25/4 is a total of negative 33/4. So that means that your vertex would be at negative 5 halves, comma, negative 33/4. Hope this helps.